welcome. This video explores types of data. In its most abstract form, data is the basis for which information can be derived. In math and science, data is a collection of facts, such as measurements, values, words, or observations. To computers, data is a structured set of numbers representing digitized text, images, sound, or video. With computers, we can manipulate data to solve problems and create digital solutions. In the following module, we'll explore the way that data is represented on computers in more detail, but for now, we'll focus on the foundational aspect of data. Data is presented to us as information in a variety of different forms. On this slide, we present a collage of some types of data representation you might be familiar with in your everyday life. From clocks, to banking, your shoe size, to bus timetables. We also have our own data, which includes things like our eye colour, our weight, and even our favourite foods. This information helps to inform us and enables us to make decisions. Data comes in different forms. Essentially, data can be numeric or categorical. Numeric data in the research world is also known as quantitative data. Continuous data includes data that can be within a measured range, for example, money, or measurements like height or volume. This type of data can include decimal places, and you can also measure between ranges. Discrete data are things that can only be counted in whole numbers, for example, 3 kittens, 2 cups, or 1 book. You can't really have 2.5 kittens or half a book. The other form of data is categorical data. In the research world, we refer to this as qualitative data. Categorical data can be nominal or ordinal. Nominal data means it cannot be ordered into a logical sequence. Some examples of this data are eye colour, gender, nationality, or text data such as descriptions about people, places, or things. The other form of categorical data is known as ordinal data, which means it can be ranked or ordered into a logical sense. For example, numbers, a scale of attitudes or grades, a deck of cards, or performance. We can use these different types of data in combination to research and describe things. Understanding types of data is important for describing attributes, which are characteristics of an object. For example, students might look at a set of coloured attribute blocks and be asked to describe what they look like. Students might describe and sort the blocks by size, colour, and shape. Describing attributes becomes an important part for identifying patterns. Students could practice collecting different types of data about themselves or other things, such as animals, and using a range of numeric and categorical data, present this information to the class. What kinds of data can we collect about ourselves? Can you remember what these types of data are? When we collect data about 1, 2, or 3 things, this might be manageable, but what happens when we need to collect large amounts of data? For example, how do doctors' surgeries manage all the data about their patients? Or what about libraries? How do they collect and maintain data about the books they have so that we can easily manage to find the information when we need it? When data gets too large, we use databases. Databases are an easy way to collect and store data. When we have too much data, things can get unmanageable. Doctors' surgeries can store patient data on paper and in filing cabinets, but by using computer systems, doctors' surgeries can more efficiently store patient data. By storing data in databases, we are able to use computers to quickly and efficiently organise, sort, and analyse data. When describing what a database is to a child, you might liken it to a toy box. In a toy box, children store all their favourite toys, which could be the data. Exploring your school library system and talking with your librarian may provide a meaningful and familiar context for understanding how databases work. Students can begin collecting and organising their own data. Spreadsheets are one way that students can begin to store data. This can be done on paper or on computers. Here I have a spreadsheet I created for planning a birthday party. I might ask myself, what kind of information would I want to collect? I want to know what foods I should make and where I should send the invitations. So I include things like name, address, whether they're attending, which I would fill in later, their dietary needs, and favourite foods. The top row of my spreadsheet includes these, and these are known as attributes. These are the facts that I want to describe for each person I invite. By looking at my spreadsheet, I'm able to start thinking about how many people will be going and what I need to take into consideration. For example, one person has a nut allergy and another person is a vegetarian. How can I make sure everyone is happy? Making sense of data is an important part because we want to make meaning with the data that we collect and put it into use. In the following lessons, we'll be exploring data representation and interpretation in more detail. Bye for now.